A new black hole has been found near our solar system, and it's also huge. This unexpected discovery opens the door to a world of cosmic possibilities and challenges everything we thought we knew about the universe. In this video, we'll explore the details of this exciting discovery, as well as other intriguing objects, some within our own solar system that will undoubtedly be talked about. Not only because of their potential risks, but because they could be a turning point in our understanding of our nearby space. To understand these exciting findings, we need to know the true nature of black holes and how it all began. Theory of relativity and black holes. Black holes were first predicted theoretically in 1916 by Albert Einstein, as part of his general theory of relativity. In his equations, Einstein found solutions that described regions of spacetime where matter had been compressed so much that gravity became extremely intense, preventing even light from escaping. A very deep gravitational well. But how is it possible for something to deform a vacuum where there is supposed to be nothing? Spacetime is a physical and dynamic entity that can be affected by the presence of mass and energy. Even if we don't see it, it is always there. It is a mathematical physical entity that combines three spatial dimensions plus time. You can see its effects from the curvature of light passing through large masses. But it was not until two brilliant scientific minds challenged the limits of knowledge in a historic bet that would change our understanding of the universe forever. In 1975, the renowned Stephen Hawking and the equally iconic Kip Thorne clashed in a controversy over an enigmatic object known as Cygnus X1. Thorne believed that this visible object with an intense X-ray source was actually a black hole, while Hawking bet against it, challenging the established notion. However, in the early 1990s, the truth came out. Cygnus X1 was in fact a black hole, marking a milestone in modern astronomy as the first confirmed black hole, an object that was already discovered in 1965 due to the presence of X-rays. This discovery was made possible by the tireless search for knowledge and the development of revolutionary technologies, such as the Uhuru Space Telescope, launched in 1970 to study the mysterious X-ray sources in space. At least 300 X-ray sources were discovered during the study. Although black holes do not emit X-rays themselves, we can detect X-ray emissions in relation to black holes that usually come from matter falling towards them. When matter such as gas or dust approaches a black hole, it forms what is known as an accretion disk. This disk is heated to extremely high temperatures due to the frictional forces and compression caused by the black hole's gravity. At these high temperatures, the accretion disk emits radiation in various wavelengths, including X-rays. In addition, matter falling towards a black hole can also form jets or jets of particles that accelerate to speeds close to the speed of light. These jets can produce X-ray emissions when they interact with surrounding material, or when they travel through interstellar space. In the case of Cygnus X1, we can detect it, because it has trapped a blue supergiant star and is absorbing its plasma, forming an accretion disk around the black hole, reaching temperatures of millions of Kelvin. Located about 6,000 light-years from Earth, with approximately 21.2 solar masses, this black hole challenges our conceptions about its size and origin. It is believed to come from a massive star of 40 solar masses that collapsed about 5 million years ago, triggering an extraordinary cosmic process. The 616 Monocerotis is another binary system containing a black hole of six solar masses, about 3,400 light-years away. Until a few years ago, it was considered the closest black hole to us. As a curiosity, on June 15, 2018, a special message was transmitted from the European Space Agency's large radio antenna at the Cebreros station in Spain to this black hole. This transmission, made in honor of the legendary Stephen Hawking and his revolutionary work in black hole physics, not only celebrates his legacy, but also marks a historic milestone: the first direct human interaction with one of these enigmatic cosmic phenomena. Although the signal will take centuries to reach its final destination in the year 5475, this transmission represents an unprecedented act of cosmic exploration. It offers us a unique opportunity to expand our horizons and better understand the deepest secrets of the universe. This is certainly an unusual discovery that has left scientists speechless. Gaia, The telescope, known for its precision measurement of the velocities of galactic objects, has revealed something truly extraordinary. The most massive stellar black hole ever found in our own galaxy, Gaia BH3. This extraordinary find has been made possible by meticulously monitoring the intriguing motion of a companion star, which reveals the presence of a cosmic colossus, whose astonishing mass exceeds 33 times that of the Sun. The curious thing is that it is not creating any accretion disk. The black hole remains quiet and does not absorb more stellar matter from its companion star that orbits the black hole every 11.6 years. Stellar black holes are formed when a massive star collapses at the end of its life cycle. Until now, the stellar black holes identified in our galaxy contained an average mass of around 10 times that of the Sun. Even the most massive stellar black hole known until recently was Cygnus X1, which only reaches 21 solar masses. This new discovery of an object with 33 solar masses is therefore exceptional, and opens new perspectives in the study of these mysterious cosmic entities. In addition to its impressive size, what makes this black hole nicknamed Gaia BH3 even more astonishing is its relative proximity to us. It is located just 2,000 light-years away in the constellation of Aquila, relatively close in cosmic terms, making it the second closest known black hole to our planet. This finding, the result of a thorough review of Gaia observations, underlines the surprising ability of science to reveal cosmic secrets hidden right on our doorstep. To validate this exciting discovery, astronomers turn to a variety of ground-based observatories, including ESO's powerful Very Large Telescope, located in the Atacama Desert in Chile. These complementary observations not only confirmed the existence of Gaia BH3, but also provided valuable information about its companion star, shedding light on the mysterious nature of its origin. Pasquale Panuzzo, who is a member of the Gaia Collaboration and an astronomer at the Paris Observatory, France's National Scientific Research Center, thinks that this type of discovery only happens once in a person's lifetime. The chemical composition of BH3's companion tells us that the star is remarkably poor in metals, and this is surprising. Although similarly massive black holes had previously been detected outside our galaxy, the direct connection with metal-poor stars was an unsolved enigma. These stars, lacking elements heavier than hydrogen and helium, were thought to lose less mass throughout their lifetime, thus conserving more material for the formation of massive black holes after their final collapse. Nobody expected this, but the most curious thing is that it had not been detected before. This black hole was always there and went unnoticed until now. Can you believe it? It's right next to us cosmically speaking, and it doesn't seem to belong to the galactic plane we're used to. It turns out that this black hole and its companion are part of something called the R2 stellar stream. It sounds like the name of a space mission. It's actually a kind of ancient stellar trail left by past galactic collisions. Imagine this, we're talking about events that happened billions of years ago. The most interesting thing is that this black hole is not originally from our galaxy, it's from a different ancient galaxy. However, 5 million years ago it joined the Milky Way. How did this happen? It's a mystery that sparks our cosmic curiosity. Black holes in the solar system? And this is even more surprising. Black holes in the solar system? This theoretical discovery is just the tip of the iceberg. It is believed that millions of black holes were formed in the early universe. The extreme tensions of space-time in the early universe could have led to the emergence of micro black holes from the size of an atom or a marble, to supermassive ones. They would be so small that they would not accumulate matter and would be undetectable. According to an article published in Life Science, they are surely made of dark matter. A black hole the size of a marble could have the mass and attraction of a planet like Earth. Then the smallest ones the size of a bacteria, their mass would be similar to an asteroid. If so, they could subtly modify the objects of the solar system and cause modifications in the orbit of the Earth. These visitors would arrive from the beginning of time once every 10 years, and would subtly modify the orbits of some planets and come within less than 2 astronomical units of the Sun. If one of them comes very close to our planet, it would cause the axis of rotation to change. For example, if a micro black hole of similar mass to an asteroid came close in an orbit around the Sun, some planets could change their orbits by a few meters. In fact, one of the hypotheses being considered is that the famous Planet 9 that has not yet been found is a primordial black hole the size of a grapefruit and of planetary mass. The icy rocks of the solar system should be close enough to this hole to be disturbed. Conclusion. These discoveries of BH3 are preliminary analyses of the Gaia telescope, and it will take several years to analyze all the data. Who knows how many more findings Gaia has sent us waiting to be analyzed. This makes us see the great diversity and beauty of the cosmos. We only detect the most energetic and massive objects, but the ones that worry us are those that we cannot detect. Those micro black holes that go down in the shadows are much more numerous, and they can be anywhere without us knowing it. The great cosmic ocean holds many mysteries, and we must reveal them before we build ships that travel to the stars.